In this video, we'll be looking at Chapter 10, Section I.2 on trigonometric identities. We'll actually be focusing more on simplifying trigonometric expressions, which act a lot like algebraic expressions. So if I give you 2 sine theta plus 5 sine theta, this is very much like 2x plus 5x. Well, we know 2x plus 5x is 7x. It's no different when we're dealing with trigonometric expressions. This is 7 sine theta. So just like in algebra, you need identical terms in order to add or subtract the coefficients. Really quickly, I'll give you one more example. Let's say we have 2 sine alpha minus 7 sine alpha. Well, 2 minus 7 is negative 5, so we have negative 5 sine alpha. The remainder of the video is going to be dedicated to factoring problems, and you should have seen factoring in an earlier class. I'll review a few simple steps, but if you need more help with factoring, I urge you to see me outside of class sometime. Before we get into doing any factoring problems, remember from our previous videos, one of the most important trigonometric identities is sine squared cosine squared equals plus cosine squared equals 1. We can use this to our benefit sometimes when we're trying to simplify expressions. I'll give you one quick example here. If I have 3 minus 3 cosine squared theta, I can factor out the 3's. Remember, the first step in factoring is always trying to find a common factor. Well, I have a common factor of 3 here, so I take 3 to the outside, and I'm left with 1 minus cosine squared theta. Now, you might think we're done, but take a look at our trig identity here. If I do a little bit of manipulation, algebraic manipulation, simply subtracting cosine from both sides, cosine squared, I get sine squared theta equals 1 minus cosine squared theta. Well, 1 minus cosine squared theta down here can therefore be replaced with simply 3 sine squared theta. So I have a nice simplified expression here, which is much less cumbersome than what we started with. And that's essentially the goal for all the problems that we'll be doing in this section and for the rest of the chapter. Now we can go the opposite way of factoring as well. We could expand an expression first and then simplify. So in this case, I have the square of a binomial, which you may have seen in a previous math class. This is a lot like x plus y squared or a plus b squared, right? This would, if I was to expand x plus y squared, I'd get x squared plus 2xy plus y squared. Well, again, it's no different with trigonometric expressions. Here I'm going to get cosine squared theta plus 2 cosine theta sine theta plus sine squared theta. But notice what happens here. I have a cosine squared theta and I have a plus sine squared theta. Does that look familiar? Hopefully it should by now. Cosine squared theta plus sine squared theta equals 1. So this simplifies to 1 plus 2 cosine theta sine theta. Now, if you need a little help with expanding binomials, or the square of binomials, remember that the square of anything is just itself multiplied by itself. So I could rewrite this original expression as cosine theta plus sine theta times cosine theta plus sine theta. And now we can use our old friend FOIL. First, inside, outside, last, to expand this expression, and I should get the same exact answer that I had before. So I'm quickly going to run through a few more factoring examples here. So here's the first one. I have sine squared alpha minus cosine squared alpha. And remember, this is a lot like x squared minus y squared. And if you remember from algebra, x squared minus y squared is simply x plus y times x minus y. Well, again, I have the same thing here. I have sine alpha plus cosine alpha times sine alpha minus cosine alpha. Here's another example. I have sine squared theta minus 5 sine theta plus 4. Again, we're using parallels here from algebra. This is a lot like x squared minus 5x plus 4. Well, I can factor this to x minus 4 times x minus 1. And so the trigonometric expression is very similar. I have sine theta minus 4 times sine theta minus 1. So really, I guess what I'm trying to get at here is in most cases it's sometimes helpful to solve the parallel algebraic expression first and then factor the trigonometric expression second. Okay, let's take a look at an example problem that ties all of these steps together. I have 3 minus 3 sine squared theta all over 1 plus sine theta. Now let's take a look at the numerator first. We've seen something similar here. I have a common factor in 3, so I can pull the 3 out, and I'm left with 1 minus sine squared theta over 1 plus sine theta. Now, you might be tempted to turn this guy into cosine squared theta, right? Which it does equal. And you'd be correct in this expression. However, if we treat 1 minus sine squared theta as a difference of squares, like x squared minus y squared, I can get this expression to simplify a little bit more. For example, 1 minus sine squared theta is really 1 minus sine theta times 1 plus sine theta. And notice what I have in the denominator. It's 1 plus sine theta. Well, these guys can cancel out, and I'm left with 3 times 1 minus sine theta. And this is a more simplified version than 3 times cosine squared theta over 1 plus sine theta. They're equal expressions, but the blue one looks a little bit more simplified. So sometimes you have a choice, and if you're not getting the right answer, take a look back and see if there's a different way that you could simplify or factorize your expression.